Alright, so welcome to this video. I'll be showing you how to find the angles between vectors. So if we have two vectors that are orthogonal or perpendicular, well, the angle between them is just going to be 90 degrees or pi over 2 radians. So that's pretty easy. But if we're given two random vectors and we're not given that it's orthogonal, well, then we'd have to use the Cauchy-Schwarz inequality, which is this right here. And basically this inequality is saying that the absolute value of u times v, which are two vectors, is less than or equal to the magnitude of u times the magnitude of v. We can go ahead and find the angle using this Cauchy-Schwarz inequality, and this is the equation you want to use. Cosine theta equals absolute value of u times v divided by magnitude of u times the magnitude of v, and solve for theta. Okay, so hopefully you understood that explanation a bit, and we can go into a problem here that's asking us to find the angle between this vector u and vector v. So we're not giving that as perpendicular, so we might as well just go ahead and start with the Cauchy-Schwarz inequality method. So we know that we start with cosine theta equals u dot v times magnitude of u times magnitude of v. So we're left with this, and we can simplify this even more, where this becomes, the denominator is going to become square root of 25 times square root of 2, just factoring it out, times square root of 4 times square root of 2, which is going to become, that's all over 11. 5 times square root of 2 times 2 times square root of 2 over 11 equals, right, this is just going to become 2. 5 times 2 times 2 is 20. 11 over 20. So cosine theta equals 11 over 20. The magnitude, to find the magnitude, it's just, for example, magnitude u equals square root of 3 plus square root of 4, square 4 squared plus 5 squared, all that square root. That's going to give you square root of 50. And do the same thing for v. So once we have this, we just go ahead and arc cos, or you could write it like that, but same thing. If you don't have a calculator, or if you're not allowed to use calculators in your class, then leaving it like this is totally fine. You're not expected to find an exact answer for questions like this. Just showing the process is enough. So yeah. Okay, so here's another question that's asking us to solve the following problems using the dot product. And so the first question asks us to find all possible values of k such that these two vectors are orthogonal. For this question, there's a special property of dot products that lets us know when two vectors are orthogonal. If we're given two vectors v and u, which are in Rn, then if v dot product u equals 0, u and v are orthogonal. In other words, the angle between u and v is 90 degrees. Okay, so let's apply this to this question, where we have k1 dot k5,6, and we want it to be orthogonal, so we're going to set the equality equal to 0. or set the equation equal to 0, sorry. So let's just solve for k. We have k squared plus 5k plus 6 equals 0. And then we're left with a quadratic polynomial with degree 2. Highest degree is 2. So we can use the quadratic formula, given this is a, b, c. Quadratic formula equals b plus minus b squared minus 4ac square root divided by 2a. On an exam, we'd have to use the quadratic formula. I'll just write this down, quadratic formula. So you get two values for k. You could either use this quadratic formula or your calculator. I'm just going to use my calculator. But on a test, like I said, you'd have to use the quadratic formula. I got k is equal to negative 2, and k is equal to negative 3. So these are the values of k that make the dot product of these two vectors equal to 0. In other words, makes these two vectors orthogonal. So question B is pretty much like the first example we did. So I want you to see if you can do it on your own and then come back and check if you got the right answer. So to find the angle between the two vectors, we're going to be using the Cauchy-Schwarz inequality again. That states that cosine of theta is equal to u dot v divided by magnitude of u times magnitude of v. And once we have this, we can factor it out even more. Square root of 9. This is just the square root of so we can write it like this. So this becomes 3, this becomes 3, and we know that 3 times 3 equals 9. So this is going to cancel out, and we're going to get 1 over square root of 2. Now to find our final answer for the angle between the two vectors, it will be arc cos inverse cosine 1 over 2 squared, or 1 over 2 square root, sorry. Question C, we have 3 coordinate points, and we have to find the angle BAC. Where the angle BAC, well, let's draw it out to make it easier. So A is always the connecting point when it's written like this. So B would be up here and C there. And this would be our angle theta. So first thing we're going to do is find AB and AC. And AB equals B minus A, which equals 3 minus 2 is 1, 0 minus 4 is negative 4, 9 minus 1 equals 8. And AC is equal to C minus A, 1 minus 2, negative 1, 4 minus 4, 0, 0 minus 1, negative 1. So we have our vectors, and we can now plug them into the Cauchy-Schwarz inequality. Therefore, theta will just equal arc cos negative 1 over square root of 2. And that's our final answer.